Okay, this video is for pre-calc. We have a test on Wednesday. This is going to be 6 problems from sections 2.5 through 2.7. Okay, so let's get started. They are rather longer problems, so let's take a look. We have a function and we have a 0 given, and we need to find all the other zeros. So if this is a 0, that means x equals negative 3 plus I. That's given. There's another 0. And the other 0 is x equals negative 3 minus I. Remember, these are what are called conjugates. And complex zeros come in conjugate pairs. The middle sign is different. Now, in order to find the other factor, we are going to use long division. To use long division, what we're going to do is we're going to take these two zeros and write them as factors. X plus 3 minus I and x plus 3 plus I. So notice all that we do is we just bring them over to the other side with x by making the signs opposite. Okay, so negative 3 becomes plus 3, positive I becomes negative I. And now we multiply. We'll get 9 terms, x squared plus 3x plus xi, plus 3x plus 9 plus 3i, minus xi minus 3i minus I squared. If you want to put a 1 there with the I squared, it might be helpful for you later on. So what cancels? The xi and the minus xi, the 3i and the minus 3i, and this I squared becomes a negative 1, which makes negative 1 positive 1. And now notice no i's remain, and we have x squared plus 6x plus 10. Okay, and this is the quadratic factor that ends up having 2 imaginary solutions. So now to find the third factor, we're going to long divide. And I'll do that right over here. We're going to long divide x squared plus 6x plus 10 into the original function. 4x cubed plus 23x squared plus 34x minus 10. Okay, so to do this, we compare x squared to 4x cubed. I need to multiply by 4x. There are 3 terms, so put over the third term, 4x. And we distribute the 4x to the x squared plus 6x plus 10. 4x cubed plus 24x squared plus 40x. We change the signs of what we just came up with, and we combine. 4x cubes cancel. 23 minus 24 is negative 1x squared. 34 minus 40 is negative 6x, and we bring down the negative 10. And now we do the same thing with the x squared and the negative x squared. I need to multiply x squared by negative 1. That'll give me a negative x squared, a negative 6x, and a negative 10. Change the 3 signs that you just got and combine. Cancels, 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 0. This means that 4x minus 1 is a factor. So if 4x minus 1 is a factor, set equal to 0 and solve. Add 1, divide by 4. 1/4 is the other 0. Now the other thing I'm going to ask you to do is write this as a product of linear factors and quadratic factors irreducible over the reals. So what does that mean? That means you just write it as the linear factor and the quadratic factor irreducible over the reals. X squared plus 6x plus 10. And what this represents is, this is the real 0, 4x minus 1, and these are the 2 imaginary, x squared plus 6x plus 10. And if you were to multiply this back out, you would get the original function. But do not. Just write it like that and you're good. Alright, so make sure you can do the problem like that. Number 2! Here comes our series of rational functions. We need to graph this rational function. First step, we factor. H of x equals, the top will factor into x minus 4, x minus 1. The bottom will factor into x minus 2, x plus 2. No cancellation of factors, so we move on. Next we find the Y-intercept. To find the Y-intercept, let all of these x's be 0. 0, 0, 4, 0, negative 4. 4 over negative 4 is negative 1. There is my Y-intercept. 0, negative 1. 3, we find the zeros. The zeros come from the numerator. X minus 4 equals 0. X minus 1 equals 0. Add 4. Add 1. There are my zeros. So right now I have 3 points. 2, 2 x-intercepts and 1 y-intercept. Vertical asymptote, step 4. Come from the denominator. X minus 2 equals 0, x plus 2 equals 0. Add 2, subtract 2. There's your 2 vertical asymptotes. 2 vertical asymptotes means 3 parts of the graph. Keep that in mind. 5. Horizontal asymptotes. I need to compare the degrees. The degree of the top was 2, the degree of the bottom was 2. Therefore, we compare leading coefficients, 1 and 1. So the horizontal asymptote, y equals 1 over 1, is just the line y equals 1. So I now have 3 points and 3 asymptotes to put on my graph. Alright, so here we go. So I'm going to label it count by 5s, just to be safe. I think that should be enough. And I'll put the points in blue. So the points are -1 on the y-axis, 4 and 1 on the x-axis. My vertical asymptotes and horizontal asymptotes I'll put in red. At 2, we have a vertical asymptote. At -2, we have a vertical asymptote. And through y equals 1, we have a horizontal. And notice I do not go through the middle of the 2 vertical. I just got to the sides. So what kind of picture do I have right now? Well, right now I know that this is a banana shape, just like that, towards the asymptotes. In here I'm not sure, and over here on the left I'm not sure. So I need more points. So 6's plot points. And to get my points, I'm going to plug in -1 and -3. H of -1 is -1 squared minus 5 times -1 plus 4 over -1 squared minus 4. The top 1 plus 5 is 6, plus 4 is 10. The bottom 1 minus 4 is -3. That's -3.3. So on the graph where x is -1, I'm going to put -3, 1, 2, 3, and a third. And this is going to be the S-curve. And we just S-curve as best we can up through. There we go. And now I try -3. H of -3 equals -3 squared minus 5 times -3 plus 4 over -3 squared minus 4. That is 9 plus 15 is 24, plus 4 is 28. That is 9 minus 4 is 5. And this is 5.6. So when x is -3, y is 5. 1, 2, 3, 4, 5.6. So it's a little bit higher than this 5th mark. So this is going to be certainly up there. Oh, that's bad. Down towards this asymptote and up towards that one. And there's the graph with the 3 pictures, the 3 pieces. Make sure you plot enough points so I know that you know what the graph is supposed to look like. Alright, very good. 3. Another rational function. You'll see that that's kind of a theme in this YouTube video, so make sure you can graph rational functions. We're going to graph this. The first thing I do is factor. The top has 2 terms. When you have 2 terms, pull out the common factor of x, x plus 3. In the bottom, it will factor x plus 3, x minus 2. Different signs, difference of 1, 3 and -2, multiply to get -6, and add to get 1. Uh-oh! X plus 3, we have a hole. X plus 3 equals 0, we have a hole at -3. The resulting rational function is x over x minus 2. Plug -3 into that resulting function. -3 over -3 minus 2. That's -3 over -5. That's positive 0.6 or positive 3/5. So your hole is located at -3, 0.6. So that's going to be an open circle on our graph. 2. Y-intercept. You can use the new function. 0 over -2. Well, that's just 0. So 0, 0 is a y-intercept. 3. The zeros come from the numerator. X equals 0. That's the y-intercept. So that's the same point. Shucks, right? You want more points? You only got 1 point now. So you have an open circle and you have one point, which is the x and y intercept. 4. Vertical asymptotes come from the bottom. What's left over? X minus 2 equals 0, x equals 2. 1. Vertical asymptote. 5. Horizontal asymptotes. Let's look at the degrees. The degree of the numerator. You can look at the new or old. It doesn't matter. Let's look at the new. N is 1. M is 1. The degrees are the same. So we compare the leading coefficients of 1 and 1. Y is 1 over 1. Y is 1. So let's go ahead and mark our picture up. I'm going to count by 5s. I think I'll be safe there. And let's see what I have. I have an open circle, blue, open circle at negative 3.6. So that's almost 1. It's a half right there. I have a x-intercept and y-intercept at 0. And now I have my asymptotes. Vertical asymptote at 2. Horizontal asymptote at 1. So I have a pretty good picture of what happens here. Connect the open circle and the closed circle. That's what that one looks like. So now I need a point over here. So I do have to plot a point. I have to plot a point bigger than 2. Let's try 3. So the last step, plot points. And I can use the new function. F of 3 is 3 over 3 minus 2. That's 3 over 1, which is just 3. 3, 3, 3, 3. Bananas up, bananas down. And there's that graph. So here's an example of a whole rational function. Again, there's a good theme here. Make sure you can do the rational functions. Oh! Big surprise, one more rational function. Make sure you can do rational functions. Here we go. So we're going to graph this guy. First thing I'll do is I'll look to factor. The top is not factorable. 2x squared plus 1. There's no common factors. It's not a difference of squares. No factor. Not factorable. Y-intercept. Let x be 0. 1 over 0. Uh-oh. That's undefined. No y-intercepts. 3. X-intercepts. We set the top equal to 0. 2x squared plus 1 equals 0. We subtract 1. Divide by 2. And now we take the square root. Uh-oh! Square root of a negative is imaginary. No real zeros. So again, nothing. So far I got nothing. Alright. 4. Vertical asymptotes. Finally, I got something. The bottom is 0. There we go. So your y-axis is a vertical asymptote. It makes sense why there's no y-intercepts then. 5. The horizontal asymptotes. We compared the degree of the numerator, 2, to the degree of the denominator, 1. Uh-oh! The denominator is 1 smaller than the numerator. Slant asymptotes, which means we long divide. X plus 0 goes into 2x squared plus 0x plus 1. How do I make x become 2x squared? I multiply by 2x. Here, distribute 2x squared plus 0x. Change the signs. Cancels, cancels, bring down 1. You are now done because there are not two terms. There's no x term to compare with x. So your slant asymptote is y equals 2x. So now I can graph. There's really not much to graph right now. I have a vertical asymptote on the y-axis. And my slant asymptote, okay, so I need to go 2 at least at every direction. For the slant asymptote, the y-intercept is 0, and I go up 2 and to the right 1, up 2 to the right 1. And here's the slant asymptote. So now I'm going to have pictures either in the 2 acute angles or the 2 obtuse. To do that, we're going to plot a point. And let's plot 1 and negative 1. So I'm going to come down here. Step 6, plot points. I'm going to do it in blue here. And we're going to do f of, let's try 1. And we get 2 times 1 squared plus 1 over 1. 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3, 3 over 1 is 3. 1 3. 1, 3 is the point. And you're up in the acute angle. So it's going to be this shape. Just like that, the U shape. Now we try -1. F of -1 equals 2 times -1 squared plus 1 over 1. -1 squared is 1 times 2 is 2 plus 1 is 3. The bottom was x, and x is -1. That's -3. Look at the symmetry. -1, -3. And you're the shape like this. And there's the picture of the graph. Alright, so there's the work, and there's the picture of the graph. So I am done with rational functions, but make sure you can do a rational function problem. Okay, number 5 here, we're going to solve this inequality and graph it on a number line. We're not going to graph it, we're just going to solve. So when you see this, you must get 0 on one side, right? This must be 0. So we're going to subtract 4. 3x minus 5 over x minus 5 minus 4 is greater than 0. And now I look to combine these fractions. There is an LCD. The LCD involves the denominators of both. That would be x minus 5 and 1. But the 1 really doesn't matter, so your LCD is x minus 5. So the question is, what is each denominator missing? Well, this denominator is missing nothing, so don't touch it. This denominator is missing x minus 5. If you do it to the bottom, do it to the top. So what do I get? Well, I now have one big giant fraction with an x minus 5 on the bottom. Parentheses or no parentheses, it doesn't matter. The top is now 3x minus 5, and now I bring the minus 4 up with the x minus 5. And now your job is to simplify the top. I'll do that right here. 3x minus 5, distribute the -4, minus 4x plus 20. Combine your like terms, -x plus 15, and that is my new top. So the new top of my function, or my rational, my rational inequality is -x plus 15. The bottom is x minus 5, and that must be greater than 0. So now that I have the top and bottom, we find the critical numbers. And the critical numbers come from the top and bottom. -x plus 15 equals 0. I'm going to add x. X is 15. X minus 5 equals 0. I'm going to add 5. X equals 5. There are your two critical numbers for this problem. Here is where we draw our number line. 5 and 15. And we choose our test intervals. Our tester points in the intervals. Something less than 5 is 0. Something between 5 and 15 is 6. Something bigger than 15 is 16. So I'm going to plug these into this factored form and see what I get top and bottom. That'll give me my sign. For 0, I get a plus over a minus. That's minus. For 6, I get a plus over a plus. That's plus. And for 16, I get a negative over a plus. That's a negative. I'm looking for when it was greater than 0. Greater than 0 means positive. I'm looking for the positive. That is between 5 and 15. Now, as a side note up here, okay, so I'm changing the problem. If it said greater than or equal to 0, equal to means brackets. However, only one of these are a defined value. This is a 0. This is a vertical asymptote. So you can only be 15 if it were to be equal to 0. So if I were to change the problem to a greater than or equal to sign, the answer would be 5 to 15, but the 15 would have a bracket around it. So be very careful with your defined and undefined values. Okay, last one coming here. Ooh, buddy, one of my favorites. Messy, messy numbers with your revenue cost ideas. So here's the revenue and cost. And again, it's stupid that they don't just multiply it out. So the revenue is 75x minus 0.0005x squared. Be careful of those zeros. The cost is there. They're measured in dollars. X represents the number of units sold. How many units must be sold to obtain a profit of at least $75,000 or $750,000? So we want a profit of at least, which is greater than or equal to $750,000. Well, remember, profit is just revenue minus cost. So we're going to throw our revenue minus cost in place of the profit. So what is our equation now? Well, the revenue is 75x minus 0.0005x squared. And now when I subtract cost, I must distribute the negative. Minus 30x minus $250,000, and that is going to be greater than or equal to $750,000. So just be careful of these signs, right? Just subtract them both. So now we put it in descending power of x, negative 0.0005x squared. Combine your 75 minus your 30, that's 45x. This is still negative 250,000, and that is still greater than or equal to 750,000. And now you must get 0 on one side by subtracting 750,000. This now becomes negative 0.005x squared plus 45x minus 1,000,000 should be greater than or equal to 0. And now we're going to use the quadratic formula to find our critical numbers. The quadratic formula, opposite of b, plus or minus the square root of b squared minus 4ac, that's your discriminant, all over 2a. Opposite of 45, plus or minus, I'll find my discriminant down here. Discriminant is 45 squared minus 4 times negative 0.0005 times negative 1,000,000. And be very, very careful. It's very easy to make a mistake here, but they should come out to be nice round numbers. Nice round numbers. In fact, a perfect square, I hope. If it does, then you did something wrong. Check your work. If it doesn't, you did something wrong. Check your work. And what you get here is 25. Very good. So this comes out to be 25, which is a nice number. That's a perfect square. It should. We're not mean people here. We're trying to just make you do problems that are more than just the basics. And then we double that a value. The 5 turns into a 10. So we get negative 0.00. These two zeros stay, but then this 5 turns into a 10. So be careful though. So now there's only 2 zeros in front of the 1, not 3. Okay? And now we get two numbers, plus and minus. So x equals, so negative 45. This is 5, by the way, right? The square root of 25 is 5. So negative 45 plus 5 divided by negative 0.001. That's 40,000. And we do the minus, negative 45 minus 5 divided by negative 0.001. And that's 50,000. So how many units must be sold? Between, if you want to do it like this, you could do it like this, 40,000 units to 50,000 units, inclusive, so with brackets. Or you could write out between 40,000 and 50,000 units. And you should put the word inclusive. Inclusive means you can include 40 and 50,000. So one of these is good. Okay? So it's a simple polynomial inequality, right? It's a quadratic, in fact. However, the numbers are messy. It's easy to make sign mistakes. I understand. But just don't. And you'll be fine. Thanks for watching the video. Hope it helped. Again, you should really watch both videos to get a good chapter review and feel prepared for tomorrow's test. All right, good luck, and we'll see you tomorrow.